Welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information for the purpose of connecting the global community of engineers, scientists, and other automotive industry experts. We are joined today by a longtime member of the AutoSens family, Mike Dempsey, Managing Director at Claytex. Mike, good to see you again. Welcome back to AutoSens.
Hi, Carl. Great to be here again.
Mike, for our first-time attendees for AutoSens, or for those who may just be coming into our community for the first time, give us an overview of Claytex. Tell us more about the work you're doing today.
Yeah, sure. So Claytex is a company I founded 26 years ago now, and everything we do here is about simulation. So we started off with modeling the simulation, the physics of how vehicles behave, their powertrain, their vehicle dynamics, how they drive down the road. And through that, we got involved in doing driving simulation, particularly into high-end motorsports, so Formula One and NASCAR. And that driving simulation took us into doing autonomous vehicle simulation. So taking everything that we did to immerse a driver into a virtual test environment, we extended that to be able to immerse an autonomous vehicle with its cameras, radar, LiDAR, ultrasound, and all the other sensors into these virtual worlds so that we can start to test them and test them purely in simulation so that it's completely safe and that we can put them into all sorts of high-risk edge cases to really understand whether the system performs and whether it is safe to deploy into the real world.
Yeah, that's exciting, especially the Formula One and the NASCAR aspect of it. Yeah, that's exciting, Mike. And for you, for Claytex, a lot of momentum in this last year. In particular, there are 2 Innovate UK government funded projects that you won last year. Tell us more about that.
Yeah, so the UK government has a group called the Centre for Connected and Autonomous Vehicles. They started a funding competition around the middle of last year, looking at how do they develop the supply chain for autonomous vehicles. And so we applied along with several partners for a couple of different projects, and we were successful in both of those. So the first one that we are working on is called DeepSafe. And really the focus of that project is how do we close the reality gap between simulation and the real world. So that's really all about making the simulator more realistic. So how do we make the traffic behave more realistically? How do we recreate all of these really challenging edge cases that have all sorts of odd things happening in them? How do we recreate those in simulation to test and challenge the AVs? And so that's a consortium of 5 different partners. It's led by a company called D-Risk, but we are one of the partners, obviously focusing on the simulation part, really looking at how do we develop our AV sandbox products to support that project, to make the simulations more realistic, but also scale that by taking it to the cloud to be able to run all of those simulations massively in parallel on a cloud system. The second project is called the Sim4CAMSens project, and that's one that Claytex is actually the lead partner. And the focus there is on modeling and simulation and testing of the perception sensors used in autonomous vehicles. So here we have a different consortium of partners covering simulation like ourselves, covering test and measurement. So we have the UK's National Physical Laboratory, who everything they do is about measurement. We also have sensor developers in Oxford RF who are developing a novel radar sensor. And so within that consortium, we are looking at how do we improve sensor models and how do we take those sensor models and validate them so that they are ready for use and safety assurance.
Mike, Claytex is the lead partner in the Sim4CAMSens project. Tell us more about your involvement there, some of your partners, and then ultimately the goals of that project.
Yes, so we ended up as the lead partner for this particular project. It's a consortium with 7 other companies. So we have RF Pro that developed a simulation platform that our AV Sandbox solution is built on. We have a systems engineering company called Syselec who are looking at the requirements for perception sensors and their use in autonomous vehicles. We have a a radar sensor developer in Oxford RF Solutions, who are producing a novel radar-based sensor. And then we have a number of academics and research organizations from within the UK. We have WMG from the University of Warwick. We have the Compound Semiconductor Catapult. We have the National Physical Laboratory. And we have ASIN, which is the Automotive Electronics and Semiconductor Network within the UK. So it's quite a big consortium that we have to manage, and we're leading them through this project. Working together, we set out to look at how do we improve the modeling, simulation, and testing of perception sensors, and really focusing on camera, radar, and LiDAR as the primary sensors that we're investigating. What we wanted to understand really and quantify are the noise factors that affect the performance of these sensors. So we all know that when it rains, cameras and LiDAR suffer from rain being there, obscuring their view. But there's lots of other noise factors that influence the performance of all of these different sensors, and they're all influenced in different ways by weather, by material properties, and so on. And so the project is setting about how to investigate all of that. And one of the first things that we started to do is testing the sensors in different conditions. And that allows us to then quantify how their performance changes. So this is all using real world testing to be able to quantify that. And that will then lead into informing the modeling and simulation tasks where we want to recreate those same simulations, those same effects in simulation, to be able to say, right, it's raining at this level, so therefore our radar performance changes like this, the LiDAR changes like this, and the camera changes like this. And to be able to have that whole tool chain and process to go from test data through to the models and be able to validate it and show why the simulation is doing this correctly and why it's credible, and therefore why you can rely on it for doing safety assurance.
We're speaking with Mike Dempsey, Managing Director at Claytex, talking about the Sim4CAMSens project, transitioning here to different weather conditions. And Mike, this is going to sound like an elementary question here, but just go with it. And I say this with snow in the forecast here in Michigan as we are recording this interview. We know that you are testing in different weather conditions, but why are you testing the perception sensors in different weather conditions, including winter conditions? Why is this important?
Well, why it's important, Carl, is that you want to be able to use your vehicle in any weather condition. And the same will apply for an autonomous vehicle. It's no good if we can't use it for half the year because it's snowing in Michigan for all of that time. But there's not really that much data available for us to understand what is the effect on the performance of these different types of sensor. And so one of the first things that we set up with the Sim4CAMSens project was, how do we do winter testing? How do we design a test campaign that we can run and we can collect data with a whole suite of sensors and see how they perform and relatively how their performance changes under different weather conditions. So within the UK, there's been a big project run by the National Physical Laboratory together with the UK's Met Office for the past couple of years, doing exactly this, but in the middle of the UK where they get a bit of rain, but it doesn't snow. And so we set out within this project to go, right, we need snow. We need those winter conditions. And so we set up a test site in Scotland, and we have a suite of 15 perception sensors running there. We have 5 radar, 5 LiDAR, 4 normal cameras, and 1 thermal imaging camera, all set up on a static test rig with static targets down our test range. And they have been sat there now for just over 2 months, and they will carry on sitting there for a little bit longer, just recording how they see those targets under different weather conditions. And so we have specialist weather instruments on the site. We have a disdrometer, which tells us how big the snowflakes are, how fast they're falling. We have a present weather sensor that tells us what the visibility is, so when it's misty or foggy. And we're just collecting loads of data on all these different weather conditions that will allow us to start analyzing that and looking at how do we incorporate these effects into the simulation. And what we're really trying to determine from this are two principal things: is how is the sensor performance affected by what's falling through the atmosphere, but also how does the surface of the targets change, and how does that affect the sensor performance? So when it's really cold, we get a lot of frost building up in front of the targets. That may or may not influence how the sensors see those targets. We're not sure, but we have been collecting the test data that we will start to analyze over the next couple of months. And maybe even by AutoSens, we will actually have some data to show. So we do have a presentation at AutoSens, and we will hopefully have some good results there to be able to show some of what we are learning through this test program.
And we'll look forward to that, Mike, for sure. We're talking about gathering this data and the importance of that, but equally important is the vehicle dynamics aspect. What is your focus here, Mike, when it comes to the vehicle dynamics side of things?
Yeah, so it's one aspect that we often see a lot of AV simulators ignoring, that they will give you nice smooth roads to almost have your vehicle glide along, but that's not the real world. I don't know about where you are, Carl, but here in the UK, the roads are full of potholes,
Right.
and you bounce along them and you crash through these things, and the sensors are going to have to cope with that.
Yes, it is same here. Yes.
So we need to be able to make sure that our simulators can do all of that. Now, I mentioned at the start of all this that Claytex has come from a background of simulating the vehicle physics and doing driving simulation. We can build those high fidelity vehicle dynamics models. We have within the AV Sandbox solution that we develop, you have high fidelity road surfaces that are built from LiDAR scans of real roads. And so they put a lot of noise into your vehicle dynamics platform. What that means is you get the vibration coming through to the sensors. So you don't have your sensors gliding nicely over the road. They're moving along and bouncing just as you do in the car. You'll see all of that with the sensors. And so that allows you to extend the testing that you're able to do. Can my sensors actually detect these objects in an edge case when we've got correct vehicle dynamics and all of that noise coming in and, I don't know, hindering perhaps their ability to detect things?
Mike, I like how you phrased it, where you have to, if you own a vehicle, you have to be able to drive it year round. And it's always a pleasure to talk with you, Mike. In this case, talking about gathering sensor data in varying weather conditions, and then introducing the vehicle dynamics aspect, because as you said, sometimes that gets overlooked, but that's important. And then as we started our conversation, about those two Innovate UK government funded projects, Sim4CAMSens and DeepSafe. Mike, just was great to get caught up with you. Thank you for being with us and part of AutoSens again. And let's do an interview like this again, hopefully sooner than later, and we can talk maybe more about some of that data that you've found. But in the meantime, thank you for being with us.
Thank you very much, Carl. Great to be here.
For more information on Claytex and to find out more about our upcoming events, see the links in the description of this video or visit auto-sense.com. That's auto-sense.com. And for more in-depth interviews like this, subscribe to our YouTube channel and follow AutoSens on LinkedIn in Detroit. On behalf of AutoSens, I'm Carl Anthony.